So here's a fun function that we can talk about, and we were just talking about oscillating without settling down. Let's take a look at it in Desmos real quick. All right, here it is in Desmos. We really only care about this as t goes to infinity, so we don't even have to pay attention to negative values of t. So this thing is getting quieter, its amplitude is dying down, and the frequency is getting higher. So it's a chirp that's getting quieter as it goes up. All right, so we saw its behavior was something like this. What can we say about that limit as t goes to infinity? So this was a chirp in terms of frequency, but then also getting quieter. Well, can I say the limit of a sum, the limit of a product is the product of the limits? So let's think about that. Limit of the product equals the product of the limits. So that would say that this is equal to the limit as t goes to infinity e to the negative t times the limit as t goes to infinity sine 20t squared. Looks okay so far. What's the limit as t goes to infinity of e to the negative t? E to the negative t gets getting closer and closer to 0 really fast with no wiggling or anything, so that limit is just 0. We can even draw it real quick. Looks like this, getting closer and closer to 0. And what is this limit? Let's draw that. That's a chirp, but it's not getting quieter. It's the same amplitude the whole time. So what's that limit? Well, it's going past, it's getting closer to 0, but then overshooting, going down to -1, then coming back, passing through 0, going up to +1, and it just keeps repeating that faster and faster. So just like for plain old sine, we said that limit as t goes to infinity does not exist. It's the same issue here. So this limit does not exist. We cannot say it's plus or minus 1. And so what's our overall limit? Is it 0 times dne? What is that? Well, this whole limit of product equals product of the limits only works if all the limits exist, and this one doesn't exist, so this rule doesn't even apply. Let me try that word again. So we need some other kind of method to be able to formally show that this thing is approaching 0, hopefully. So what we can say is a common method in math is to say, well, I've got this horrible complicated function. Let me put an upper bound on it and a lower bound on it. And those bounds, if they're easier to deal with, then maybe I can say something. So we can draw our curve again and say what function is always on or above that? Well, e to the negative t, because this is e to the negative t times something that's always between plus or minus 1. And what function is always below the curve? It's negative e to the negative t. And those are fairly easy to deal with. So what I can say is, using the fact that the sine wave is always between plus or minus 1, I can use the same theorem we used before for the x going towards something finite, but now x or t is going towards something infinite. That's the Squeeze theorem. So remember how we set that up. Make a statement about something that's fairly obvious and everyone believes is true and is fairly simple, and then make it more complicated as we go along. So we could say -1 is less than or equal to sine of anything is less than or equal to 1. It doesn't look like our problem yet. Let's put in for the sine wave what we're actually taking the sine of. So -1 is less than or equal to sine of 20x squared less than or equal to 1. And now let's get our exponential decay in there. So we'll multiply each term by e to the negative t. So that's the graph we just drew there. But it doesn't say anything about limits yet. So let's take the limit of each part. So t goes to infinity, -1 e to the negative t, less than or equal to limit e to the negative t sine, oh, I guess I should have a t here, sine 20t squared, less than or equal to limit of 1 times e to the negative t. And what is this limit? Well, e to the negative t is going to 0. -1 is just a constant multiplier. So here I get 0, less than or equal to the limit I was curious about in the first place. The one we were starting with. And what is this limit? E to the negative t is going to 0 as t goes to infinity. So our limit, whatever it is, some horrible thing, is between 0 and 0. So our limit must be equal to 0. E to the negative t sine 20t squared equals 0 by the Squeeze theorem. All right.